Light possesses absolutely no beginning in any temporal sense. Allow that single compact declaration to settle fully into your awareness for a moment, because this one observation carries a capacity to dismantle and unravel every assumption you have ever carried about the nature and structure of the cosmos. This is not being stated for the sake of drama, and it is not an attempt to manufacture a feeling of wonder through clever wording or rhetorical devices. It is being stated because it stands as a direct, inescapable, mathematically rigorous, and experimentally verified consequence of the single most thoroughly battle-tested and relentlessly confirmed theoretical framework in the entire history of human intellectual achievement, special relativity. That theory has been subjected to the most intense scrutiny millions of times over, and has passed every single one of those tests with complete success. And what does this theory declare without the slightest ambiguity? It declares that from the intrinsic perspective of light itself, no time whatsoever passes. Not a vanishingly small fraction of a second, not some infinite decimal approximation approaching zero, but exactly, precisely, and permanently zero. Let us truly sit with the full weight of what this means. It means that a photon of light did not spend 13.8 billion years traveling across the vast reaches of the cosmos before finally striking your retina. From its own internal frame of reference, the photon left its point of origin and arrived at your eye in one and the same instant. There was no voyage, no duration, no elapsed interval of any kind, and therefore no beginning to its existence at all. So when cosmologists state that the universe is 13.8 billion years old, they are describing a duration to which light itself remains fundamentally indifferent. And when the question is asked, how old is light? One is posing a query that physics itself declares to be fundamentally unanswerable, because light does not merely lack a beginning. It does not experience the passage of time in any form and never has. Why, then, do we continue to operate under the assumption that it must possess one? I know exactly the thought process that is occurring in your mind at this moment. You are almost certainly regarding this as nothing more than a clever verbal maneuver, a sophisticated manipulation of reference frames crafted to sound profound. You are likely saying to yourself, very well, that may hold from light's own perspective, but we ourselves are not light. We exist inside a different frame of reference, and that is the frame that matters for our everyday experience. And you would be entirely correct in that assessment as far as it goes. Yet here is the crucial point that such a response, while accurate on its own terms, completely overlooks an insight of enormous importance that most science communicators are either too cautious to voice openly or have not themselves thought through to its full conclusion. That crucial point is this. If we employ time as a means of defining the age of the universe, and if light operates entirely outside that temporal framework, then light is in no way, shape, or form constrained by the age of the universe. This is not a philosophical curiosity to be pondered in isolation. It generates a genuine, tangible difficulty, a difficulty that confronts not only philosophers sitting in armchairs, but physicists who are looking directly at observational data that stubbornly refuse to conform to predictions of the standard model. It is a difficulty already staring us in the face, and it demands our complete and undivided attention. Before we proceed any deeper into this line of inquiry, I want to be entirely transparent about the method by which this discussion operates. I am not going to quote a celebrated physicist and then ask you to accept that person's authority as final. I am not going to prescribe what the single correct interpretation of the evidence must be. Instead, I am going to walk you carefully and methodically through the actual experimental results, the robust mathematical frameworks that support those results, and the verified physical consequences that follow from them. And then I am going to place the conclusions back into your hands, because that is what intellectually honest science looks like. It is not about deference to authority. It is about following the methodology wherever the methodology itself leads. And if at any point along this path you experience a sense of frustration, I want you to hold on to that feeling. Frustration is a natural response that arises when an existing mental model collides with a real feature of the world that the model simply cannot contain. That feeling is not confusion. It is your mind actively detecting a contradiction that your prior education never equipped you with the conceptual tools to resolve. Most people instinctively flee from that uncomfortable sensation, but the fact that you have engaged with this material tells me you are different. So we will not flee. We will go deeper into the heart of the issue. There are four foundational concepts that you must grasp firmly before the central argument can land with the full force it deserves. And I will be completely honest with you. I am constructing this deliberately rigorous. I am not doing so in order to display technical sophistication or to artificially extend the length of a discussion. I am doing so because if these four pillars are not locked solidly into place, everything that follows will feel like abstract philosophy. And it is not philosophy. It is physics, the most fundamental physics we possess. So stay with the argument while we build this structure from the ground upward. The very first thing that must be secured is a precise understanding of what a reference frame actually means within physics. This is not the casual, popularized version that might appear in ordinary conversation. A reference frame is, in essence, the coordinate system from which every measurement is performed. When you remain at rest and watch a car travel past you at 60 miles per hour, that velocity is the car's velocity as measured inside your particular reference frame. But from the driver's own frame, you are the one who is moving at 60 miles per hour in the opposite direction. And here's the critical insight. Both of these measurements are equally valid. Neither one is more true or more real than the other. This is not a statement of philosophical relativism. It is a physical fact that has been confirmed by countless testable consequences. Now the stakes become extraordinarily high. In 1905, Albert Einstein demonstrated that the laws of physics, including the inviolable speed of light, are identical in every single inertial reference frame. That proposition may sound reasonable and straightforward on its surface, yet the logical conclusions that follow from it are nothing short of mind-bending. If light always travels at the same speed, no matter which frame is used to measure it, then time itself must be the quantity that varies between those frames. The universe adjusts the flow of time in order to protect the constancy of the speed of light. The universe has no interest in protecting your personal experience of duration. Its sole concern is invariance of the speed of light. You are the variable, light is the constant. And once that radical inversion of perspective is genuinely internalized, physics ceases to be a mere collection of disconnected facts and transforms into a single coherent and deeply unsettling argument. The second pillar that must be established is the concept of time dilation. And here is essential to set aside every analogy you have ever been given on this topic, because a majority of those analogies are incorrect in precisely the ways that matter most of present discussion. Time dilation is not an illusion. It is not a trick of perception. It is physically and demonstrably real. We know this with absolute certainty because it has been measured. When atomic clocks are placed aboard commercial aircraft flying at ordinary speeds and then returned to ground, they are found to be measurably out of synchrony with identical clocks that remain stationary on the surface. The difference is extremely small at those velocities, yet it is undeniably real, and it matches the equations of special relativity to an extraordinary degree of precision. The GPS satellites that enable the navigation systems in our phones experience time dilation of such magnitude that if engineers did not actively correct for it, positional errors of several kilometers would accumulate every single day. This is not a purely theoretical concern. It is a concrete engineering requirement for modern technology. Time dilation is as real and tangible as gravity itself. Now consider what the fundamental equation reveals. As velocity is pushed toward the speed of light, the time experienced by the moving object, what physicists call proper time, becomes progressively smaller. As the velocity of an object approaches c, the speed of light, its proper time approaches zero. And at exactly c, proper time is identically zero. For a massless particle such as a photon, which by the laws of physics must travel at precisely c, no proper time elapses between any two events along its path, ever. The photon that departed a star 10 billion light-years distant and has only now entered the mirror of your telescope did not experience a 10 billion-year journey. It experienced no journey whatsoever. From its own frame of reference, the emission and the detection were simultaneous. The journey you measured lasted 10 billion years. The photon measured nothing. The same events, the same photon, two completely irreconcilable durations, and both of them are physically correct. This is not a paradox. It is a fundamental feature of the universe we inhabit. The third foundational concept is the space-time interval. This is the crucial bridge that connects the preceding discussion to the larger argument we are constructing. Within the framework of special relativity, there exists a quantity known as the space-time interval. customarily denoted ds superscript 2. This quantity elegantly unites space and time into a single unified geometric measure. For ordinary massive objects moving through the fabric of space-time, this interval is positive and finite. But for light, for photons, the space-time interval is exactly zero. Physicists refer to the corresponding path as a null geodesic, a trajectory through space-time that possesses zero length. Reflect on the profound implications of that fact. Between any 2 points along a photon's world line, the space-time distance is effectively zero. The photon's point of origin and its point of destination, no matter how unimaginably far apart they may appear within our reference frame, are geometrically adjacent within the four-dimensional geometry of space-time. The photon does not travel across the universe. In a very precise and literal geometric sense, it does not travel at all. It simply connects two events that space-time itself regards as coincident. And I want you to sit with that realization for a moment, because this is the point at which most discussions of the topic come to a halt. They present the mind-bending fact, and then quickly move on. Yet the implication of a null geodesic is not merely that light possesses no proper time. It is that light possesses no space-time extent whatsoever. It exists, in the most literal geometric sense, outside of what we call the timeline of the universe. It is a denizen of a different order of reality. The fourth and final foundation is the cosmological timeline itself. According to the standard model of cosmology known as lambda CDM, the universe began in an extraordinarily hot and dense state roughly 13.8 billion years ago. In its earliest moments, the universe was an opaque fog of plasma. Photons were continually scattering off free electrons and could not travel freely through space. Then, approximately 380,000 years after the Big Bang, the universe had cooled sufficiently for electrons and protons to combine and form neutral hydrogen. The universe became transparent, and the photons were finally released. This monumental release is what we observe today as the cosmic microwave background radiation, or CMB. These ancient photons have been traveling for approximately 13.4 billion years, and we now detect them as a faint, nearly uniform glow of microwave radiation arriving from every direction in the sky. Now, this is a juncture at which the central question of the entire discussion becomes utterly unavoidable. We confidently state that those CMB photons are 13.4 billion years old. But from a photon's own frame of reference, they are 0 seconds old. They were emitted and detected in the same instantaneous moment. So when we declare that the universe is 13.8 billion years old, we are describing a duration that is real and profoundly meaningful for every particle that possesses mass, for every clock, for every observer who experiences the flow of time. But light, the primary means by which we observe the universe, the very medium through which almost all of our cosmological data reaches us, exists entirely outside that description. We are employing an ageless messenger to reconstruct the history of a universe that is defined by its age. And at no point in conventional education does anyone pause to ask whether this arrangement creates a fundamental measurement problem. Before the actual data are brought forward, I want you to form a prediction. On the basis of what you now understand about null geodesics, proper time, and the cosmic microwave background, commit to a position regarding whether the phrase the age of the universe retains a physically rigorous meaning when it is applied to light itself. Think the matter through carefully. Do not simply react on impulse. Actually reason it out, because most people, when they first encounter this idea, tend to move in one of two directions, and both of those directions miss something critically important. Some will say, yes, of course age applies to the universe as a whole rather than to the individual photons, and those CMB photons are 13.4 billion years old in the only frame that truly matters, ours. Others will say no. Age is a frame-dependent quantity and is therefore entirely meaningless when applied to anything traveling at the speed of light. Commit to one of those two positions before we continue, because in a short while both of those answers are going to appear incomplete in ways that matter enormously for how we fundamentally understand cosmology. We are about to test those assumptions against the cold, hard reality of the observational record. Here is what the data actually reveal. The WMAP satellite and, more recently, the Planck satellite have produced the most detailed maps of the cosmic microwave background ever obtained. What they found was astonishing in its precision. The CMB is almost perfectly uniform across the entire sky. The temperature variation from one point to another is less than 1 part in 100,000. And this extraordinary uniformity gives rise to a significant difficulty known as the horizon problem. The regions of the early universe that emitted the CMB photons we now receive from opposite ends of the sky were, at the moment of emission, separated by distances so vast that they could never have been in causal contact with one another. There simply was not enough time, even at the speed of light, for any information to travel between them and equalize their temperatures. Yet we observe that they are at exactly the same temperature. The standard response to this conundrum is a theory of inflation, which proposes a period of exponential, superluminal expansion during the universe's first fraction of a second. That expansion would have stretched a tiny, causally connected region to the size of the entire observable universe. Inflation is a compelling and elegant theory. It accounts perfectly for uniformity of the CMB and the flatness of the universe. It even generates predictions that subsequent observations have confirmed. But here is what is rarely stated in the same breath. Inflation remains a hypothesis, a very well-supported hypothesis, yes, but not a confirmed certainty. And here's the point that bears directly on our argument. The horizon problem exists only because we are making a set of fundamental assumptions. We are assuming that causal connection requires the passage of time. We are assuming that signals need duration in order to travel across space. We are assuming that the history of the universe is strictly a temporal sequence. All of those assumptions work perfectly for massive particles, but photons are not massive particles. And the horizon problem looks very different indeed if one takes seriously the fact that, from the standpoint of photons null geodesic, the entire observable universe is in a geometric sense already connected. I am not claiming that this definitively resolves the horizon problem. What I am saying is that almost no one is asking this question with sufficient urgency, and it is a question that deserves our full attention. Now, let us turn to what occurred in 2022 and 2023, because the James Webb Space Telescope fundamentally altered the conversation in ways that are still sending shock waves through the physics community. JWST was specifically designed to look farther back in time than any previous telescope. Its first deep-field images were breathtakingly beautiful, yet what they revealed was also scientifically uncomfortable. Webb discovered fully formed, massive galaxies at redshifts corresponding to a time less than 700 million years after the Big Bang. These were galaxies that, according to our standard models of structure formation, should not have had sufficient time to assemble into such large and organized systems. The standard model of cosmology maintains that after the release of CMB, matter required hundreds of millions of years to clump together gradually under the influence of gravity. Small structures first, then larger ones through successive mergers and accretion. This is known as hierarchical structure formation. Webb's early galaxies simply do not fit inside that timeline. They are too large, too structured, and too chemically evolved to have formed within the time the model allocates to them. And the response of the physics community has been precisely what honest science looks like. It was neither denial nor silence. It was genuine, palpable uncertainty. New models are being proposed at a rapid rate. Modifications to the behavior of dark matter, alternative scenarios for inflation, the introduction of early dark energy. None of them has yet resolved the tension definitively. And underlying every one of those proposed solutions is the same foundational assumption, that we can use light to measure time, and that the time light has been traveling is a straightforward proxy for the age of the structures it reveals. Webb found galaxies that should not yet exist, and every proposed solution continues to treat the travel time of light as equivalent to the developmental time of the universe. But what if that assumption is precisely the location of the difficulty? What if the problem is not with the galaxies, but with the measuring rod we are employing? This is the point at which I am going to ask you to do something genuinely difficult. I want you to hold 3 competing interpretations of everything we have established so far simultaneously in your mind without forcing them into a single tidy answer. This is a juncture at which most science communication fails its audience. It selects the neatest interpretation, presents it as a consensus, and then moves on. This discussion refuses to do that. So here are the 3 frameworks that physicists and philosophers of physics actually debate when they work through the profound implications of null geodesics and cosmic time. The first interpretation is the relational time view. This position holds that time is not a background feature of the universe that exists independently of the things within it. Instead, time is a relationship between physical systems. Specifically, time is defined as what clocks measure, and a clock is any physical system that changes state. Light, however, does not change state internally as it propagates through space. It possesses no internal clock. Therefore, asking about light's experience of time is not a deep question about the nature of reality. It is a category error. The question, how old is light, is analogous to asking what is north of the North Pole. The conceptual framework that generates the question simply does not apply to the subject matter. Proponents of this view, who often draw upon the work of physicist Julian Barber and his investigations into timeless physics, would argue that the age of the universe is defined by the progression of massive clocks, and light simply is not one of them. The difficulty with this interpretation, however, is that it does not explain why light's null geodesic carries real, tangible geometric consequences for how we measure the structure of space-time. It answers the temporal question, but sidesteps the geometric one. And that sidestep is not a minor omission. It is precisely the location where the real tension in physics resides. The second interpretation is the structural realism view. This position argues that what is fundamentally real are not the individual objects of physics, but the relationships and the underlying structures that the mathematics describes. According to this view, light's null geodesic is not a limitation or an anomaly to be explained away. It is telling us something profoundly true about the inherent structure of spacetime itself. Specifically, it is telling us that the universe does not possess a single unified temporal structure in which all physical entities participate equally. Massless fields occupy a fundamentally different geometric role from massive particles. They do not evolve through time. They connect points across spacetime. And the history of the universe, as we reconstruct it from light, is therefore not a direct readout of what occurred in a temporal sense. It is a projection of a geometric structure onto a temporal framework that applies only to a portion of what exists. The implication of this view is significant and far-reaching. Our cosmological timeline is real and meaningful for the matter content of the universe, yet it may systematically misrepresent the behavior of the fields, particularly the electromagnetic fields, that we use to observe that matter. We are reconstructing the history of the cosmos with a messenger that carries no memory of the journey it undertook. This could explain, at least in part, why Webb's observations continue to surprise us. We are reading a temporal map that was drawn by something that has never lived inside time. The third interpretation is the modified cosmology view, and this is where the discussion becomes most technically contested, yet also most consequential. A growing number of physicists, including those publishing peer-reviewed work as recently as 2024, have begun to explore whether the concept of universal age is operationally well-defined at all, not philosophically, but operationally. That is to say, is there a physical procedure one could carry out that would yield an unambiguous answer for the age of the universe independent of which type of physical system is employed as a clock? For massive particles and atomic clocks, the answer is yes. For photons, it is demonstrably no. Some researchers working in this area, particularly those involved in quantum gravity approaches, such as loop quantum gravity and causal set theory, suggest that time itself is an emergent property rather than a fundamental one. At the deepest, most fundamental level of physical description, there is no time. What we call time is what arises when the underlying quantum gravitational degrees of freedom coarse-grain into the smooth space-time we experience in everyday life. And if time is emergent, then the question of what light experiences is not a question about a special case. It is a window into the pre-emergent, timeless structure of reality itself. This interpretation is the least settled, yet it is also the one most consistent with the frontier of theoretical physics in 2024 and 2025. Its strength is that it naturally accommodates both the null geodesic result and the anomalies in large-scale structure formation that Webb has revealed. Its weakness is that it is radically incomplete. We do not yet possess a working theory of quantum gravity. We have approaches, frameworks, and candidates, but none of them has been confirmed. So this interpretation is honest about what we do not know in ways the other two are not. At the same time, it offers at least immediate traction for generating specific, testable predictions. You almost certainly disagree with at least one of those three frameworks. That is good. I want you to disagree with one of them. Not because disagreement is an end in itself, but because the moment you feel resistance to one of them, you are doing physics. You are actively asking the question, what would have to be true for this interpretation to be correct? And more importantly, is that something I am prepared to accept on the basis of the available evidence? That is not a rhetorical question. That is the actual intellectual work. 3 frameworks. 3 completely different answers to what light's timelessness means for cosmology. All 3 are supported by legitimate physics. None is definitively proven. That is not a failure of science. That is what the frontier of human knowledge actually looks like. And most channels simply will not show you that unsettled truth. Now I want to share where I personally land on this issue, and I want to be extremely precise about what I'm doing when I say that. This is not a final conclusion. It is not a statement of what the science definitively says. It is simply one interpretation of what the science makes available. And I am offering my reading so that you can push back against it, refine it, or reject it entirely. That is the only honest way to engage with this material. The null geodesic result does not feel to me like a category error. It feels like a signal. When a physical framework returns 0 for a measurement, that is usually not an indication that the question is malformed. It is usually an indication that 0 is the actual answer, and that this answer carries deep implications we have not yet fully followed through. What I think the null geodesic is telling us is that the universe contains 2 genuinely different kinds of physical existence. One that fully participates in time, the matter sector, which includes massive particles, atoms, galaxies, you and me, and one that connects points in time without residing in it, the radiation sector, which includes photons and the electromagnetic field. And the fact that we construct our entire cosmological picture, our timeline, our distance measurements, our age estimates, and our structure formation models, almost entirely from the second category, while assuming it behaves exactly like the first, strikes me as a foundational assumption that deserves far more scrutiny than it currently receives. Research from groups working on causal set theory, particularly work published in Physical Review Letters in 2024 that examined discrete spacetime structure and photon propagation, has begun to probe exactly this boundary. It is not yet mainstream, but the questions are being asked, and I believe that within the next decade the answer to where light sits relative to time is going to force a genuine revision in how we speak about cosmological age. Not necessarily a revolution, but a necessary and profound refinement. I think we have been building our cosmological timeline almost entirely from the testimony of something that does not live in time. And I think that fact is going to matter more than we are currently willing to admit. What is your interpretation of all this? I mean that genuinely, not as a standard invitation for comments, because the 3 frameworks I have presented certainly do not exhaust the space of all possibilities. If you believe there's a 4th, more compelling reading of the null geodesic result that resolves the tension more cleanly, I genuinely want to hear it. If you believe I have made a philosophical leap that is not justified by the physics, then please make that case. This discussion exists in the space where the data end and interpretation begins, and that space belongs to everyone who is willing to do the intellectual work required to occupy it. Now, here is what this discussion is actually prepared, because we have been building towards something throughout the entire argument, and if you felt that accumulating momentum, you were absolutely right. The question we have spent this entire examination wrestling with, whether light has a beginning, whether it participates in time, whether our cosmological age measurements are frame-dependent in ways we have not fully accounted for, possesses a direct, immediate, and profound descendant. And that descendant is this. If time is the quantity that light fundamentally does not experience, and if quantum mechanics tells us that the act of observation collapses probability into reality, then what does it actually mean for a photon, an entity that exists entirely outside of time, to be observed? What is the measurement process due to something that possesses no temporal position? The measurement problem in quantum mechanics is usually presented as a puzzling quirk of the very small, a difficulty concerning electrons and slits and observers. But when it is combined with what we have established here, it transforms into something much larger and much more unsettling. The next discussion in this series is titled "The Observer Has No Location: What Quantum Measurement Does to Timeless Particles," and I want to be completely direct with you. That discussion is not optional if you wish to grasp the full argument. What we have accomplished today is the establishment that light possesses no temporal frame. What the next discussion will establish is what observation actually means when the thing being observed has no position in time. Those two pieces together produce a problem that neither quantum mechanics nor cosmology has cleanly resolved. And I believe that when you see it laid out in its full context, you're going to understand why some of the most serious and thoughtful people in theoretical physics are extremely uncomfortable with the standard textbook answers. What does observation do to something that exists outside of time? Quantum mechanics does not possess a clean answer to that question, and that gap is not a minor technical detail. It is the next great problem on the horizon. Before you do anything else, I want to ask you to save this discussion. I know that may sound like a standard closing request, and I understand if you're skeptical, but here's the actual practical reason. Studies on information retention consistently demonstrate that complex conceptual material loses roughly 70% of its retrievability within just 48 hours without reinforcement. What we have covered today: null geodesics, proper time, the three interpreter frameworks, and the connection to the web anomalies. These are not simple facts that can be easily reconstructed from memory after 2 days. They constitute structure, and structures require the ability to return to the exact moment at which particular piece of that structure clicked into place. Please save this discussion so that when the next installment establishes a measurement argument, you can easily return to the specific sections here that connect directly to it. I am not asking you to do this merely to support the channel. The argument we are constructing across this series functions only if you can actively hold the earlier pieces in mind when the later ones arrive. You will not retain 70% of what you have just encountered within 48 hours. That is not a criticism of you. That is simply neuroscience. Save the discussion. The argument works only if all the pieces can be held together. Subscribe if you want the next discussion to reach you when it becomes available. And I want to explain why the subscription matters specifically for this series. This is not built around individual, standalone installments. It is built around a cumulative argument that develops across a sequence of episodes. Each discussion assumes a working knowledge of the previous one. Each interpretation builds upon the framework established before it. If you encounter the measurement problem discussion without having engaged with this one, you will still have an interesting experience, but you will not receive the full argument. The subscription is a means by which you remain inside the continuous sequence rather than encountering fragments of it at random. This is not a collection of interesting videos. It is a single coherent argument constructed across a series. And every installment you miss is a piece of structure that you will have to rebuild painstakingly from scratch. And right now, do not stop. The next discussion is already available. It is called The Observer Has No Location: What Quantum Measurement Does to Timeless Particles. Do not deliberate. Do not open another tab. Begin it immediately, because the fundamental thing we established today, that light exists entirely outside of time, becomes the exact foundation upon which the next discussion opens. And if you pause now, you will lose a momentum that allows the subsequent argument to land with the force it is intended to carry. Everything we have done today was carefully constructed preparation. The next discussion is the point at which it all detonates.